Howdy. That's extreme weather seen from eastern Finland towards the west. Let's increase a bit contrast and such things because that's widescreen, so it isn't that sharp. But there is action going on. Very nice details were visible. I don't know if they are visible here in this picture, but let's have a look. Yeah, they're also a little bit visible here. I was talking about these. They were really geometric in shape, how to put it, equally spaced and such things. We have few lower clouds here in the front and higher clouds up here, which have very nice filamentary structure. We have layering going on. And we are looking at this from approximately here. So we see the edge of this cloud, and it has already brought flooding and stuff into Finland. And there is more coming later. Let's see if there's anything going on in this region here. Yeah, they're like really at the border. There is sometimes stuff going on, but not over the plasma rock site. Not over the plasma rock site here. And that's quite a massive cloud. That's big. And I somehow expect to read tomorrow in the news, or already in the night there will pop up news about extreme weather in Finland, like lightning and water and all these kind of things, what you need. And this will still continue for, I don't know, one day or such. Which is good because I didn't got the chimney yet ready. If it waits until tomorrow with the rain, I would be pleased. But let's see how it goes. They are moving very fast. Maybe I should show you this other picture because they are going now here in the middle, approximately upwards over the sea. And I once created this picture. That's a surface conductivity anomaly, which was originally part of this page. That's a screenshot from the page, and there is like data and other maps and all these kind of things. That's just a picture. The plasma rock site is somewhere here located. No, it's not. Probably here. It's a bit hard to say because that's what we have. This is Outokumpu. It's not too far from here. So we are in the red area. And here, maybe I have to change the color. Here we have somewhere the Kursk magnetic anomaly. Then I took the screenshot, laid it on here and made it bigger and tried to fit it as good as possible, playing around with lines. Felt that this doesn't really work. This might work. Because I think these red areas are positive charged areas and these are negative charged. So they will spin in this direction and they will spin in this direction. This would explain how we get this airflow going up here in the middle. Straight up here, where we have the boundary of minus, Let's draw a minus here, a very nice minus, the minusest minus on the world, and the plus. And that's the region where they touch each other. There has been, I have not yet checked where exactly, these flooding things going on. But I would expect that we would hear something from this area, Oulu region, Pohjanmaa. Let's say from this region. There might be some reports about flooding or whatsoever. Because it is the region where the positive makes a turn and there is the negative, and they meet here approximately. If we go back to this picture, it's not that well visible. Maybe we have to check this other one out. This one. Here it says Oulu, which is Oulu, which is the city I just showed you. And you probably observed here that here it seems to be very dense surface conductivity. And here it's also like quite dark blue. So you can expect that that's a border of charge differential. So we have to expect, especially in these regions, heavy downpours and all these kind of things. And probably also here in Lapland, or especially here, where they touch each other. But I don't know. I have been trying to ask. Oh no, I'm not sure. I haven't tried. I asked people about this and about this, because that's a surface conductivity anomaly on ground. Okay, but it will affect the weather. It will affect the weather, and the Kursk magnetic anomaly is very strong. It's one of the strongest in the whole world, obviously. And since Earth's magnetic field is weakening, magnetic field is weakening, the energy flow which goes through our planet, it goes both directions, of course. The energy is fluctuating. We have CMEs coming in. There was a bunch of flares today, and the coronal hole stream, and they will all hit together at once. Might get really interesting. Just because of the fact that there is so many different events happening simultaneously. CMEs, solar flares, coronal hole stream. And it could make Earth's magnetosphere wobble and stuff. So there could be this kind of magnetosphere holes and stuff, and all these kind of things. And Finland is located very at the north. And here we have the polar cusp. Incoming solar wind particles which go into Earth and go into Earth, and stuff will go back out and so, because Bergland currents, they work in both directions. This is the cusp reconnection, what we just saw here, polar cusp. Which goes straight into Earth's electric circuit. Observations. Fusilier van Dratnerwang Lavarot. Ground-based low reconnection cells, particle signatures. In situ spacecraft observations, remote particle signatures. So that's the picture of the cusp reconnection. And I noticed once that there is quite much similarity to the surface conductivity anomaly over or in Scandinavia. It touches almost all Scandinavia, Norway, Sweden, Finland, Russia, some of the Baltic states, maybe even Denmark, I don't know. So there are striking similarities in these two pictures. Of course, here on the right side we have basically the opposite of the one of the bigger picture in the middle. But there will be an opposite of everything. And I was thinking once, if there is fluctuation in this stream which comes in and goes out, maybe this region was once here and thus created the surface conductivity anomaly. I don't know. This is just a thought. If this is bouncing up and down through extreme solar weather or whatever events were taking place back then, polar configuration, Venus comet, and all these kind of things. If this polar cusp region, which is quite far away from Earth, has touched once Earth's surface through fluctuations within the cosmic currents, and if you would scale this up to a cosmic, like intergalactic scale, the distance from here to here would be almost zero, because Earth is very small compared to many other planets. Our sun is very small compared to other stars. And we are just one of trillions and trillions of solar systems within space. So after all, this distance between here and here is very, very little compared to other things what we found. So I think it is totally possible there has been once a fluctuation, and this polar cusp region, which looks like this obviously, has touched Earth's surface and left this as an imprint. And I was thinking about the polarity of this. I don't know. It can be, it is totally possible that this imprint didn't happen when this place was in the north as it is now. It could have been in the south. Like if Earth's rotation would have tilted, like how many degrees? 180 or 90? Danish Janibekov effect, tennis racket effect. So that's why I think this surface conductivity anomaly has its own charge. It will react to its environment according to its own charge and polarity. So if it's positively charged, it will attract high pressure systems which spin in this direction. If it's negatively charged, it will attract more like low pressure systems which spin in the opposite direction. So there is a channel basically here in the middle which sucks things up. And if they are like enough strongly active or charged, they will interact with space weather and all these kind of things, stellar currents and like. But I don't know who to talk about this. So I talked to my phone about this. This channel here, which creates through the polarities of this region and this region, this kind of sucking motion, it will just pull things up there in the north. Is through the weakening magnetosphere and all these kind of things, their effect on weather might just increase. So 20 or 30 years ago, like the Kursk magnetic anomaly probably didn't have so much influence on the weather here. I don't know. I'm just about 2 years thinking about this since I found that, and like, it's still under investigation, the whole thing. But if you look at this map, there is like a huge channel here. And if you watch Windy, there is the Kursk magnetic anomaly, and there is this negatively charged. This is pushing this way, and this is this way. So there will be this kind of channel in the middle. And here is the boundary between plus and minus. So you can expect there happening something. Of course, like, this is also dynamic. Things are changing rapidly. Like this, what is it called? North Atlantic circulation, Gulf Stream, westerlies. No, these are winds. The circulation here, which should bring us warm weather and all these kind of things. It doesn't seem to. It already started last year, like at the end of the year in fall, it was really visible that there isn't any more any circulation going on. Furthermore, there isn't any hurricane still. I was too quick. There isn't any hurricane still going there. Because, just look at it. Things are moving to the wrong direction. Hurricanes should go there, but stuff is coming from there. It is totally the opposite. Or do I see ghosts? No. I don't. And there is also, I have been reporting about this like many months ago already, when I noticed that there is something from this region trying to go up. And now it seems that it really has established a connection. Oh man. A connection from here straight to the Alps, over the Alps, straight into Scandinavia, and out of the picture into the North Pole region, where it might make a U-turn. Let's check it out. Does it make a U-turn? Different height, we probably would see better. Yeah, that's some wild weather. Does it make really a connection? No, yeah, but it's not at the same place. I was talking about this region, but it makes a connection here. Check it out. Jetstreams are turning around. Wow, that's quite something. Jetstreams are making a U-turn over the Atlantic and coming back. Yes, good news for Florida. No hurricanes. Doesn't mean that there isn't any bad weather, but at least they make a U-turn and come back into Europe with full blown and go straight up into the Arctic. Spitsbergen, Svalbard, where we have all the seeds of the world buried in a mountain. It's on Svalbard, Spitsbergen. Yeah, but I think I'll leave it here. This could be endlessly continue this theme, because it's quite all encompassing. We are all in this together. Strap your hat and get your boots. it's gonna get rough. But anyway, thank you. Bye.